all the repercussions of different versions of Revit and backwards compatibility, things like that. But for now, we're going to go just open an existing Revit address, and this is the West Wind Apartments. It's a multi-story apartment unit, which is very typical of a lot of the work we're doing these days. So let's open that. In the electrical folder where you would normally have found CAD files, now we have also Revit files. The main one we're looking for is this here. It's got the project number, name of the project, electrical, and which version, and followed with the RVT. That is an electrical version 2020 Revit file. And what this means is it's going to create a local copy of the Revit project onto my local PC. And we'll show you later how that gets synchronized with this master model that's on the server. Anyway, so that's just going to open up. And it says I'm trying to create a new local copy with the same name as one I already had. That is normal. Every time you open up the model, it's going to overwrite the old local copy because I want the most current information. So overwrite. This is a good size project and good size model. So it will take a minute or so to open. You can see the progress at the bottom left. It's going to open this project. You can see already the ribbon has a lot of information on it. We will cover this in future lessons. I'm going to hit some highlights today just to show you again what's the benefit of doing all of this in Revit for the electrical discipline. Okay, it's open. It automatically starts at a thing called the project starting view. This is so that we don't have to generate some kind of a 3D view or a complex two-dimensional view just to open our project. It defaults to this. What I want to cover first is this pane on the left. It's called the project browser. And right now it's got a lot of things open. I'm going to start closing down some of these tabs so we can start from fresh. Okay, this is kind of like an explorer view of the entire project. It breaks things down into different views and sheets and schedules and things like that. So I'm going to cover some of the basics. The first thing is views. Views are kind of like a model space. We can have, I'm going to jump to the electrical views. And again, this has a lot of things open. I'm going to close this down for simplicity. You'll see electrical and lighting, power and telecommunication. We have one model that's shared between the electrical and technology. Don't worry about some of the question marks. Some things have been unassigned. But I'm going to start right now with a coordination view. Again, these are just kind of a model space view of our project. They aren't sheets that you would print. These are just working drawings. So I'm going to start right off with this 3D view. Okay, there, that looks like a mess. This is a 3D view, of course, of the building, and what you're seeing is all of the electrical pieces. We've got switchboards and lights and load centers and even receptacles. You can see the junction box. All the electrical devices. This is an electrical view, which is right now not very easy to read. The right part of this is the properties palette. And CAD had properties palette, but it wasn't quite as busy as this one. This one has a lot of information that we'll have to cover later. But for now, what I'm going to do is just change the discipline from electrical to coordination so that it will change what I see in this 3D view. And apply it. It takes a minute. There. This is more of an architectural view of the building. You can see that it's very detailed. We can change, we can rotate it, we can change, pick top left corner. This is handy for a good 3D representation of your building. You can zoom in with the scroll wheel. You can hold down the scroll wheel button and pan. A lot of what you'll learn is how to navigate through here. Scroll back out with the wheel. So this is kind of an overall view of the building. You can also have internal 3D views, and some have been created. You can create as many as you like. Here's one called an art space, and it's just a kind of a wireframe drawing. You can change how this looks. I can go realistic, and it will shade it for me. You can see some light fixtures arranged in a triangle. And as I'm hovering over things, they highlight. This is an electrical fixture, a duplex receptacle. So these are actual, what they call families. They're actual entities within the project, not just two-dimensional. There's an exit sign back there. So there's 3D. This is used for kind of visualizing your building, and it helps with that. It's not usually used for doing the modeling. So let's jump down now to the actual electrical. We have elevations. If I go to a south elevation, again, this is an electrical view, so it has all the electrical panels and devices. But the main information I want to show you here is that buildings, of course, have different floors or levels. Well, these are actually an entity that can be modified. We can move this level from 0 to somewhere else. These levels are copied in from the architectural model so that they match. But we have control over them. So here's all the levels, level 6. I tend, just to let you know, I'm kind of a zoomer. Zoom in, zoom out, but you can also just pan. So even the penthouse floor, and these are exactly the same height as the architectural model. The other thing is grids. You'll see that the grids highlight as I go over them. These grids are actually in our model. They were copied from the architectural model into our electrical model. So we have control over where they are. If I want them higher, I can move them. The architectural grids show behind, but we can turn those off. This is most useful in a plan view. But so that kind of shows what's happening there. You can also create elevations that are zoomed in and things turned on and off if you want to show those on your sheets. Let's go to electrical details. These are called drafting views. They are just two-dimensional drafting views. Here's a lighting control diagram that is just, it's just drafted. It's just lines and text. Click on that. Over here, it's text. 330 seconds aerial using a loop for a leader. You can see there's a loop here. That can be changed to all kinds of different things. We can have an arrow instead. Very easy to change, very easy to add another arrow. So that's handy. I'm going to undo that for now. But it's just text. This is just text. This is just lines. Lines, medium lines. You can have thick lines, thin lines, dashed lines. So it's just a two-dimensional type thing. Even our feeder schedule is a drafting view. So it's just lines. And there's a few symbols that have labels that can be changed, things like that. But it's drafting. Then we have the meat and potatoes of this lighting. For example, we have ceiling plans and in floor plans, two different kinds of plans, and we'll cover that later. But the ceiling plans, for example, let's go to our first floor lighting plan. There you go. That looks like kind of a standard black and white two-dimensional CAD. Now what's different about this is a lot of these symbols are what I would call smart symbols. They're families that contain data. For example, a lighting plan. Here's a light fixture. If I highlight it, I click on it. Over here in the properties, there's a lot of properties associated with this. Let me focus on a few. First of all, the name of this family is a custom family that we've made, and we've given it the name Fixture F08. We've given that. It tells you it's on level 1. It tells you how high it is. It's hosted, actually connected to the linked Revit model. We've linked in the architectural model. This light is attached to it, and so it knows what height it's at. It's a surface light fixture. I can control whether it shows the emergency circle, filled in circle or not. I can uncheck emergency, and now it's just a simple open circle. Click it back on. That just is a visual thing. We can do some lighting calculations if we have the appropriate data. I don't typically do that yet. This tells me that it is already connected to panel E, circuit number 4. That's internal data that it knows where it's connected to. I connected to it earlier. Just some other information that's not important. It can, if you have a multi-phase project or let's say a remodel, this can be existing versus new. And then the electrical data, it says it's a 120 volt connected at, and it's a 30 VA. Light fixtures have a load associated with them. A nice thing about that is, let's say I need to, this here, that's not text. This fixture identifier is actually called a tag. This one is a custom lighting fixture type tag. It gives you the fixture type, F08. I didn't type that in. I said tag this light fixture, and it brings out the information within the light fixture. If I go in here, and this is a way to edit what's in the light fixture. Here's another screen full of data that you'll learn. But the main point here is that this light fixture type, right now, I've called it type mark F08. I'm going to change that to F25. Apply it. Okay. See that tag? It changed. Not only there, every instance of that light fixture now is tagged with F25. I did not have to retype any text. This is smart. It knows that this fixture is an F25. Now, I didn't change the name of the family there. I only changed the type mark. Normally, I will do both. But I just want to show you the power of changing a light fixture type from A to B to whatever. Automatically is reflected in the entire model, not just the floor, not just the room, the entire model. That's very powerful. That's light fixtures. We have different light fixtures already set up there. Here's an exterior type fixture, a wall mount decorative light, custom. Again, it's hosted. It's hosted to the model, the architectural model. It's connected to panel E, circuit 2, and the load is also 30. So that's how light fixtures work. Even exit signs. These here, you can have a double exit sign. So you have two faces or a single face. That's just a graphics thing. But it's tagged also. Now, the circuiting. These are just wires. They're a graphical entity that Revit will put for you if you say add wiring. But it can be modified. You can stretch the arcs however you like. You can change the connection point. It's smarter than just arcs. It'll even put a home run for you. And it can do some wire sizing for you. if you look at this now, you wouldn't have a number 8 ground in this. So this isn't set up yet. I don't use it for wire sizing, but it is smart in that, again, this piece here is not text. This is a tag, a smart tag, a wire tag, and it reflects the circuit that this light fixture is attached to. So panel 1A circuit 16, if I click on this light fixture, there it is. It's connected to panel 1A 16. Revit knows it and labels the home run appropriately. If I were to change where this light fixture is connected, that's a whole other process, but it's kind of like I click tab a few times to get to the circuiting data. Now, electrical circuits. Here's a bunch of information here. But what I can do is I can change up here what panel it's connected to. I could connect it to one of my other panels. Here you go. I want to connect it to panel 1C. The tag just changed. It connected it to a spare or open circuit on panel 1C. Now, every single light fixture that was on that previous panel, including these, everything is now connected to panel 1C34. You can see the power in that. I don't have to go changing circuit numbers. It's done automatically because it's tagged. The other thing on this, let's go to back to a light fixture, edit that light fixture. Now let's say that we've made a design decision. We want to go to a smaller, a lower lumen, lower VA, lower wattage fixture. I'm going to change this to 25. This fixture type F08 now is a 25 VA fixture. Apply that. Now every instance of that, well, we changed it to F25. Every fixture now is 25 VA. That is, as you'll see, reflected in the panel schedule. This was an F09. It did not change. It's still 30. But all of the now F25s would be changed in the entire project. Here we go, F25, 25 VA. Again, powerful interconnection of these things. Here's our grids we were talking about. We have control over them. I can move them closer. They kind of stick together. That's very helpful for graphically making things look how we want. We don't rely on the architect's grids. Same thing with room names. This is a room tag. You'll see that a lot. Tags. It is tagging this red outline, which is a room. If I was to go to annotate and room tag and drag that over, you can see that it automatically uses the name of that room that is in the architectural model. I don't have to type in text. I can just tag it. That's powerful too. If they change the name of this room in the next model, this tag will change. Now, if they delete the room, you'll also lose your tag will be dumb. But that's a whole nother issue. That kind of covers lighting plans. Let me jump over now to a power plan. This is a floor plan, not a ceiling plan, and you'll see the difference later. What we have, similar things. We've got room tags that we placed, but now we have power items. We have receptacles. Here's a receptacle. It's a smart family, like a light. Click on that. It is a custom MFI duplex receptacle. We have a standard. We have different kinds of receptacles. You can add more. We've got a standard. We've got above counter. You can even have them labeled, or not just labeled, but set up for certain types of equipment, a refrigerator. And what that does is it lets you assign electrical data to that receptacle type. It's kind of like a light fixture type. It's a type that's used over and over in the model. It's linked to the wall. It has a panel and circuit assigned to it. And it has a load. Similar to light fixture, I can jump in here. This is a type. Now, if I change this, it will change all of the versions of this standard duplex receptacle. So I can change the load from a standard 180. I can make them, 200 if I needed to. That's mostly useful when you're changing other things like a refrigerator. You can change this instead of a 1200 VA load. Let's go with a 1500. That kind of thing can be done. But again, it changes it everywhere. If I change this type of standard receptacle to something else, it changes everywhere, including, as you'll see, the panel schedule. Circuiting similar. We've got it set up to just put some tick marks in the home run. This is a tag. If I was to circuit these differently, that would change automatically. Let's look at a panel board. Here's a panel. Okay. Magnify a panel board, custom panel board now that gets specific. This one's a 208 main lug only, surface mount, 225 amp. You click on this, you can see there's, down here, there's many other kinds. We have different amperages. We can go with a recessed versus surface. We can go with a main circuit breaker versus main lug only. So there's many different choices. And it can be changed easily. If I want to change this to a recessed, I can simply find the recessed version of my main lug only. Boom. Boom. Now it's recessed. It even shows that it's recessed in the wall. I'll undo that. So things are very changeable. Now that this looks funny, there's a home run on a panel. This is mainly a flag to me that it tells me that I have electrically connected this panel to something upstream. So, like I say, in this properties box, there's a lot of information here. It'll be hard to absorb all of this right away, so we'll just hit some highlights. Again, it's linked to the host. Now, there's a whole section on the electrical loads. It keeps track of every electrical load connected to this panel. Phase by phase, load by load. You can see its receptacles. It's got connected. It's got a demand. It applies the proper demand calculations, such as the first 10 kVA plus half the rest. It does all of that. It's all built into this smart panel. No more spreadsheets. It's all built in. Some other things here. Let's see. Let's go to the general. It's a surface mounted. This I can give it a panel name. I called it 1B. It tells you where it's located. It knows those smart rooms. It knows where it is. A bunch of electrical information here. If we wanted 42 circuits, we can change that. The mains are set up here. We can change all of this. This is misleading main circuit breaker rating. It says just one because it's actually a main lug only panel, so this is irrelevant. Here's the voltage it's at. That can be changed. It tells me that I've connected it to the main distribution board, MDB. 4-wire, 3-phase. There's no load on that. So that tells me that it's connected to something above. There's a tag from MDB. This is my actual main distribution board. Again, it's a custom family MFI switchboard at 208. It's got an amperage. There's different versions. We can go 800 amp. This one only has 800 and 2500, but there's a lot of others in the template if we need them. Then you get all of the electrical load information. Now this is reflected also in a schedule type of view, not just here. This is the kind of a tabular properties view of it. But you can see that there's parent load, connected load. It's broken up into types of load: HVAC, lighting, receptacles, heating, and even elevator is separated out. Equipment, dwelling units are separated out. You'll see later that's very valuable if you want to fill out a utility load sheet. Things are broken out into different load types. We can change the dimensions. I gave it a name. electrical circuiting and sizes and voltages and how many breakers and all that kind of thing. So that's a smart switchboard. Here is a smart equipment connection. Click on that. This is a customized equipment connection. I labeled it electric heater. It's connected to panel 1C circuit 29 and 31. So it's set up as a 208 single phase. Revit calls it two phase because it's line to line. For example, down here, electrical data 208 volt 2. It's two phases. And I have it set for 3500 VA. Again, if I go to that editing that type, here's all of the data that's contained within that 3.5 kW electric heater. Here's all the data. There's the load, voltages, phases, what classification. This is where I can tell it that I want it to be. Oh boy, there's so many. I can make it a dwelling unit, electric. I can make it an elevator. I can make it heating. I could change this to HVAC, which I typically like to do also. So I have a good record of all of the HVAC loads. But anyway, you can pick a load classification so it knows how to apply a demand factor. It's very, very intelligent. Give it descriptions. Here, this little tag means I'm going to make it on an equipment schedule, which I'll show you later. So it will automatically schedule all of this information onto a schedule that I do not have to create in Excel. That's the equipment connection. Here's something similar, a motor connection, different symbol, but similar information, circuiting information. I can show the disconnect or not. Let's unclick it. No disconnect. Just a graphical thing. I can also add a fuse or not show the fuse. Again, just kind of a graphical thing. Here we go. This is another tag, but this is an electrical fixture. The motors and receptacles and such are actually called fixtures in Revit versus equipment like panels and switchboards. But this is a fixture, electrical fixture tag, and you can do it with a leader line or without. We've got it set up with this symbol. It automatically fills in, like a light fixture, automatically fills in the type name. So if I was to change this from GEF to something else, it would reflect automatically here. Things like I don't have a model for a generator itself that could be created or a family. In this instance, I have something called a electrical cabinet, which is kind of a generic box that can be sized however we like, just to represent something that doesn't need to be circuited, something that's just taking up space. Let's see what else we have. That's the main pieces. Again, here's a floor box. It's a symbol, floor box receptacle. It has a load associated with it. So loads can be changed. You can easily duplicate connections. You can easily schedule them. So that's the power plans. Now let's jump down to another thing called legends. These are kind of like the drafting view I showed you. For example, our symbol list is a legend. It's a two-dimensional drafting. This is just lines and circles and text. Notes can be done as legends. Legends can be installed or placed on multiple sheets. So very handy if you have keyed notes that would be the same for every power sheet. For example, general notes. You can put these same notes onto every one of your electrical power sheets. One line diagram. This one's done as a legend. Sometimes we do them as a drafting view. Similar, it's a two-dimensional. So what we have is we have a number of symbols created. You click on that, it's like a block. It's a symbol that's a symbol family labeled one line circuit breaker vertical pointing up. It has some labels that can be filled in. Now these aren't smart symbols, they're just two-dimensional dumb symbols, but we've got different line types. This is a extra wide line for a bus. We have, of course, fuses. You can fill in all the labels. It's kind of like, again, just a two-dimensional drafting view. But panels, they have a label you can fill in. Drafting is, for two-dimensional, is kind of nice. You can take things and you can grab that and it's connected. I can drag that around and you can see it's still connected. So things are connected. If I want to line things up, I can do that. If I want to, let's say I hit text and I want to see how that dash line means that this text is going to be lined up vertically with that. It's lined up. I can also line it up horizontally. You'll see that line there. So things can be lined up. There's automatic construction lines. So drafting is pretty handy here. So that's a legend. Now let's get to schedules. I told you about the equipment that I put in, and I used that equipment EQ UIP tag to tell it to schedule it. Now if I click on the equipment schedule, this whole schedule was created from the electrical model from the devices that I put into it. So when I added AC1 as a motor connection, I called it AC1, I gave it a load, and it reflected all that information here. Now some of the information I can actually edit here if I want to change the description of it, or I can actually jump back in the model and edit it there. So a number of things you can modify in multiple places. But if I modify it here, it's modified on the plan as well, so I don't have to do it in two places. The only thing I've added to this schedule is the circuiting. Instead of putting conduit wire, I use a scheduled feeder and branch circuit table. So this is a 30 amp 2-wire circuit. But I wrote that in as text, but everything else here came from the model. When I circuited that air conditioner to panel 7B, it reflected it here on the equipment schedule, so I've not had to add that. That's very powerful too. Same with lights. The light fixture schedule was created by Revit from the light fixtures that I put in. If I was to change this type, it would change it on the floor plan as well. As you can see, my F25 is down here. It used to be F08. It changed it here. It changed it everywhere. So anything I do here, some things you can't change here, but some things you can. But wherever I change it, it changes everywhere. And I can go to the right, and you can see this schedule is pretty minimal. It ended up on this project. The architect was doing more of the fixture schedule than I was. This is mainly for my circuiting purposes. So schedules are very powerful. Now let's look at panel schedules. These are created by Revit from the model, panel 1A. I typed in the description, but it brought in the load for me. It added up all the receptacles connected to this circuit and shows the load. If I was to go back into the power plan, change the receptacles from 180 to something crazy, 500 VA, it would add all those up, recalculate them for me, and give me the answer. I don't have to go counting receptacles of different loads. I don't have to go through counting light fixtures of all different loads, and when they change, recounting. It's all done within here. So that's, again, very powerful for us. It, of course, adds up all the loads, separates them into categories that we assigned when we installed the receptacles and the lights. It gives you all the classifications. It applies appropriate demand factors, 125% for lighting. It came down to 82.89% because that's the first 10K plus half the rest. And here you go. That's panel schedule. So for every panel schedule, it has this information. Here's 5A. It's all done automatically. Any loads that I change, I go back to the model, change that load there, and it gets reflected here. Let's look at a sub-distribution board. It's a different format. This is based on a switchboard template. And this is, instead of, like a panel, this is just showing circuits like 3-phase or 2-pole circuits. Each of my studios are connected to a switchboard. It applies the connected load. You can even see I'm sub-feeding from SDB1. I'm sub-feeding a subdistribution board 7. It brings that load in also. These happen to all be dwelling units, and it applies the appropriate demand factor based on how many dwelling units are attached to this switchboard automatically. I don't need to go through and count dwelling units and decide which demand factor from the NEC. So again, that's all done here automatically. And as I change things, it gets reflected everywhere. So now we will go to the main distribution board. You will see I have all of my panels connected, other sub-distribution boards connected, the elevator connected, all the connected loads. And then it breaks up all the loads into their classification depending on how they were assigned when I created the model. I told the elevator it's supposed to be an elevator classification. We've got multiple elevators, so it gave me some demand factor. This is all done automatically. These kind of load classifications are handy to fill out utility load sheets. They like things divided up. Very, very powerful. I've said that a lot, but it's very true. It's very powerful for us electrically. So there's all the pieces of my model. To create sheets, you can see these are all the sheets. These are sheets that you would print. Cover sheet, for example. Oh, don't need to save it right now. Normally when you work on a model, you want to save it every time it pops up. But I'm just showing you this model. So what we have is of course, a title block. Again, it's just another family. We got this, pulled this out of the architectural model so that it matches the architects. Even all the information, like the project and stuff, address, job numbers, we import from the architectural model, so we don't have to type that in. We've put our stamp in here. This is our logo that we put in here. Sheets are just assembled. We throw a title block in it. This fixture schedule, let me delete it. What it actually is, this is just under legends, a symbol list. I'll just drag that onto my sheet, place it. In this case, I can change to no title. I can change the title. There. That is how you assemble a sheet. Kind of like a viewport. You just drag and drop. First floor plan was created by dragging, let me delete it, dragging the lighting plan from my lighting view, drag it over, find a good place to put it, click, there it is. I can change the title to say something different. This is just dragged on here. Same with these notes, were dragged on from my legends or drafting views. So sheets are simply dragging. If I want to change the name of a sheet, I can do rename. I can change the name. If I change the name here, it will be reflected on the sheet itself. If I change just E201555, which is silly, but let's do that, you can see that it changes it here. So I guess what I'd call that, it's all interactive. Roof plan, same thing, just dragged over. One line diagram, a sheet with a title block, a logo, and the one line diagram is a separate piece that was just dragged onto the sheet. I can move the title, schedules, sheet. I dragged on equipment schedule. That's just a piece that I can drag. You can actually resize some of this if you want to. This was the feeder schedule that I just dragged on here. And then individual panel schedules, again, were just dragged from the left onto my sheets and just organize them nicely. They will tend to line up with those dashed lines. If I want to line them up horizontally, pretty much drag and drop. Same with the detail sheet. Looks like we don't have one here. Those are some extra sheets that we did not use. So that is the sheets. Last thing I'm going to show you is the list on the left here of all the families. These are all the individual little pieces that we've used to assemble our model. Annotation families. Click on that. There's just, there's so many. It's a huge list, but one-line symbols, annotation symbols, all kinds of grid symbols, all these things. If you need to use these for one line, you can drag them from here, kind of like a palette. So I can, I don't need a view title, but let's say I have a north arrow. I can just drag it, a north arrow, and place it. So I kind of use this as a tool palette to drag and drop things. Let's get away from the annotation type symbols and let's go look at some electrical equipment. Here's all the families of the panel boards and switchboards and transformers. It makes most sense if I go to an actual plan. Let's go to a first floor. We don't have a site plan on this project, but let's go to a floor plan. I can simply go up to my dry type transformer, or let's go to a pad mount. I'm going to put a 500 kVA pad mount. I'm going to drag it, and now I can locate it. And spacebar actually rotates things. I can rotate this pad mount right here. So that's a pad mount, and this actually shows the utility clearance. So we have a lot of families or symbols already pre-made. These can be modified with some help from the Revit department here. We can help you modify things if needed. But drag and drop is how things are installed. Panel boards can just be dragged in. There's a way up top to go to a systems tab, and you can install electrical equipment devices from here. That's one way to do it. Drop downs, you can try that. I have found personally that I prefer to have everything in my project browser. It seems more intuitive to me to drag it from here. The electrical fixtures I was talking about are receptacles and equipment connections and motor connections. You can see every single motor connection is a separate individual family type. They're like light fixture types. These are types. That way they can be electrically connected individually, even a fire pump. So it adds up to a lot of pieces that you will do individually, but you can see the power of those. Lighting devices. Light switches are individual. Fixtures. Here's all the light fixtures. You can see the generic name for this surface dome, but I've got a bunch of types within that surface dome category. So you can create all of these. Anyway, it just has a lot of devices here. Each one has its own information. Do them one at a time, and it adds up to a full project. There's even things like walls and stairs. These are all the architectural families. They're all listed here if you need them. The last piece I'll show you is the printing. So we've got our sheets made. If I want to print this, let's say to Bluebeam, make a PDF set, I just go up to the quick access print button. It's similar to CAD. I can pick Bluebeam. What I can do here is I look at print range. I can pick a selected view, views and sheets. I can tell Revit which sheets and views I want printed. Now we typically just print sheets, not the views themselves. So I unclick views. Now I see all the sheets available to me. I don't need to print start here, but I've decided to print all of these electrical sheets, and I can save them as a name. That set I can call the electrical set, save it as that. Every time I want to print the electrical set, it will remember. So okay, I want to print that set. Now it can create separate files if you need separate sheets. I like to combine them all into one single file. I just take the default name. I can change that later. And then down here, I want to tell it what size. These happen to be, well, we can go 30 by 42 or 24 by 36. I would have to look at the model to remember which one this is, but let's assume it's this. And say, okay, it's going to, takes a while, it's going to generate each sheet, and then it will print them to PDF. But it's printing every sheet all at once, kind of like a CAD publish. It will print them all, and I told it to put them all on one PDF. So it's doing its thing. It's going to, here we go. It just gives it a name, which is fine. I can change it here. Let's call it, let's just call it West Wind Apartments Electrical Bid Set. There we go. And I'm saving it into a folder on my local computer. It's going to do all of its printing and converting. Again, this is a good sized project with 20 or 30 sheets. So now they're done. And they will be a PDF document on my local computer that I can copy to the server. You can also print, of course, directly to the printers, the KIP or the Konica, if you so desire. Seems like most of my prints are PDFs. So in a nutshell, there is your entire review of a completed electrical project. I hope you can see how powerful the circuiting is. Creates smart schedules and does a lot of load tabulations for you. The only other one piece I want to show you, you can tell I haven't shown you much of the 3D aspects. We don't use a lot of 3D aspects in electrical. I mainly use it for showing switchboard sizes and panel sizes, and sometimes light fixture locations. Architects like to have those installed 3D wise. Also, any large feeders we should probably be showing. There's a way to model conduit in Revit for the large feeders that traverse up and down through a building. We'll go over that in a future video. But for now, let me show you one 3D aspect. Up here, I can set a camera inside my electrical room. I can say I want to point this way, and it's creating a view. As you can see, there's not much to see there. That's electrical. Let's go to a coordination view. It's such a small room. Now, if I hit F8, I can use a look, and I can look around this room. And you can see the light up there, my switchboard. There's a receptacle. Here's my switchboard. There's panels on the right. So it's a tight room. But in a more open room, for example, this, look at this retail space. I can drop a camera here, aim it this direction, change it to coordination discipline. And it's going to vary depending on the architectural model. Some architectural models are detailed, some are not. This one apparently is not super detailed. And this is kind of an empty room. But you can see the idea that you can drop this camera wherever you like. You can also drop in sections. Up top here, there's a section button. I can cut a section anywhere I want. There, I'm cutting a section through this building. Now it's going to cut a section through all the floors. So if I double click on that, now I get a section view of every level. I'll zoom into this one room I was in, and you can see now I can see the wall. Coordination view. I can see the architectural elevation. I can see if my receptacles are at the right height and the right location. I can coordinate with maybe some equipment. Here's light fixtures. So you can use this for placing things and coordinating things. Since I have control of my own levels, I can typically drag them. This view is not set up for that, but sometimes you can drag levels out of the way. Let's do another section. Here's a section that cuts through the entire building. There. See, now you can see how handy this is for getting an idea spatially of the building. Sometimes you'll end up with very complicated levels, multi-level stair-stepped buildings, partial basements, raised stage floors. You can see here the architect has a number of other levels that we have not copied. We don't need them for our purposes, but if you do, you can copy them over.